I'm Desmond Edagese, and I welcome you to Maths class. Today we'll be looking at a theme, number and numeration, and also we'll be learning about the topic, simple equations and variations, part 2. In our first class, we learned about direct variation and inverse variation. Well, in this class, we'll look at the other types of variations that we have. We'll be looking at the remaining 3 types of variations. 1, we'll learn about the joint variation. We'll also learn about the combined variation. And finally, we'll learn about the partial variation. They are all very interesting, and it promises to be an awesome time. The first variation we'll be looking at today is the joint variation. Now, what exactly is the joint variation? When we have a variation where one quantity varies as the product, that's the key word, the product of 2 or more other quantities, we have what is known as the joint variation. So, quick recap. Remember we said in the direct variation, y is directly proportional to x. In the joint variation, that relationship would be y is proportional to xz. Okay? So there is a product of other variables that are connected to the variable y. So y is proportional to the product xz. The equation is of the form y is kxz, where of course by now we know that k is our constant of proportionality. Joint variation is just like our direct variation, but in this case we have a product on the other end of the relationship, and all the variables are directly proportional, but they are taken one at a time. Now there are steps to solving problems in joint variation. Let's look at some of those steps. The formula method and the proportion method can be used, but let's quickly learn about the formula method. Find k from the formula. Y is kzx. Of course, k will be y all over zx. So, values for y, z, and x would have been given, and then we can go ahead to calculate our value for k. When we have that value, we create a model equation. Okay? We simply impute that value of k into this equation here to become our model equation. So here's a sample of a model equation. We have y is equals to 10zx. This equation, our model equation, of course, can help us find our unknown. How do we do that? We simply plug in the known variables. For instance, z and x may be given to us, and then y may not be given. So y is the unknown. So if we have those values, we simply plug in, for instance, z, and plug in for x. Multiply that by 10, and we'd have a value for y. And that's how you find our unknown value. Let's go ahead to carry out some practical examples. X varies jointly with y. Jointly. Note the key words, jointly. So you know that it's not a direct variation, okay, but a joint variation. X varies jointly with y and the square root of z. So there is a product y and z here. When x is minus 18 and y is 2, then z is 9. Find y when x is 10 and z is 4. So first step, quickly find the equation of relationship. X, we've been told, is jointly varied with y and the square root of z. So y and the square root of z is the product of y and the square root of z. So we have x proportional to y square root of z. Okay, the equation would be x is ky square root of z. K is introduced as our constant of proportionality. Okay, let's quickly impute the values that we know. X is given to us as minus 18. So we say minus 18 is equal to, y is given to us as 2, so we impute that value 2, and z is 9. So we impute that as square root of 9, of course, is 3. So 2 times 3 is 6, minus 18 is 6k. To find k, we simply divide both sides, divide through by the value 6. So k isolated is minus 18 over 6, which is minus 3 in value. Now we have a value for k. We take that value and put it back in the equation of our relationship. Okay? And that, of course, will give us our model equation. So this becomes our model equation. X is equal to minus 3y square root of z. Now let's go back to plug in our values to find our unknown y. Okay, for our second ratio, we have values y unknown, x is 10, and z is 4. So we plug in values for x known and z known. So x is what? 10. 10 is equal to minus 3, y is unknown, and z is known, 4. So root 4. Root 4 is same as 2. So we have minus 3 times 2, which is minus 6. Minus 6y is equal to 10. To get y isolated alone, what do? We divide both sides by minus 6. So y is equal to 10 over minus 6, which gives us minus 5 over 3. Y is minus 5 over 3. And that's the value. Let's take another question. In this instance, we'll be making use of the second formula, which we've learned over and over again. We simply create two ratios, of course, and equate them to each other, since they are constant ratios. So if y varies jointly, take note again. So you need to find out what relationship exists in the question. In this case, it's a joint variation question. If y varies jointly as x and z jointly, so there is a multiplication here to give us a product, and y is 12 when x is 2 and z is 3. Find y when x is 7 and z is 4. So using the second method, which we said is faster if you already have a deep understanding of the subject, what do? Create two constant ratios quickly. So we have y1, x1, z1 is y2, x2, z2. So remember where we started from. We said y varies jointly as x and z. And of course, this gives us the equation y is k, x, z. K, of course, is our constant of proportionality. And of course, isolating k would have k is y over x, z. And of course, k is a constant, so we can equate two ratios that are equal to each other. And that's how we created y over x1, z1 is equal to y over x2, z2. So what do? We simply plug in all our known values at once so that we can find the unknown. So we know what y1 is. y1 was given to us as 12. We know what x1 is. Okay? x1 was given to us as 2. We know what z1 is. It was given to us as 3. Those are the first set of ratios. So we simply quickly put in that as 12 all over 2 times 3. Okay, for the second set of ratio, y2 is our unknown. We've been asked to find y when these other values are in place. The second set of our ratios. So our y2 is unknown. We know what x2 is 7. And we know what z2 is 4. So we have our equation set out. Okay, we simply do a quick multiplication there. 12 over 6 is y2 all over 28. 12 over 6 is 2. So 2 is y2 all over 28. To isolate our y2, what do? We multiply both sides by 28. So y2 is isolated, and we have 28 times 2. This, of course, is what? 56. So the value we seek, y2, is what? 56. Now let's do some word problems. We said this relationship, that is the joint variation relationship, can be found in real life situations. Let's see how they apply in this question. For a given interest rate, okay, simple interest varies jointly. So again, you quickly know what relationship is in play in your question. Jointly, as principal and time. Principal and time, we'll have our products there. If 20,000, okay, left in an account for 4 years earns interest of 320 naira, how much interest will be earned if you deposit 5,000 naira for 7 years? So quickly, it's your prerogative, that is, it's your duty, to quickly get out some variables to represent some of these important factors. So we say let x represent the simple interest. Let y represent the principal, and let z represent the time. These are the key actors in our question. For a given interest rate, simple interest varies. Simple interest varies. So x is our simple interest, varies jointly as principal and time. So we have principal and time as the other actors. Principal is y, time is z. So we have x varies as yz. Okay? Of course, we further can go on to say x is k, y, z. Okay? So now we can impute values and then find our unknown. Okay, so let's quickly see if we can find our k. K, therefore, would be what? X over y, z. All right, so x is given to us as the simple interest, 320. Okay, and interest of 320. So our x here is 320. All over our y is the principal. What is the principal? The principal here is 2,000 naira. 2,000 naira was the initial sum, that is the investment sum that was left in the account. So we have 2,000 times, we have our time, 4 years. 4 years, time in years, 4. Okay, so our k is 320 all over 2,000 times 4. 2004 is 8,000. 320 over 8,000, if you divide that, would give us 0.04. So k, our constant of proportionality, is 0.04. We are using the first method. Okay, so we know what to do. We impute this value of k in our initial equation to get a model equation. So we know k now to be 0.04. We say x therefore is 0.04yz. Now we have a model equation. What do we do? To find how much interest that will be earned if we deposit 5,000 for 7 years, that would be the second end of our ratio. Okay? So we know that x is the simple interest and it is unknown. So we say x is unknown. 0.04 has been given to us as our value for k. Y, which is the principal, is 5,000 naira, the money left for 7 years. So we impute or we plug in 5,000 naira to represent y. And z is the time in years, 7 years. Okay? So we have all of that plugged into our model equation. X therefore is 0.04 times 5,000 times 7. This would give us 1,400 naira as our interest for 7 years if 5,000 naira is deposited in the account. Let's take a look at another real-life example. Wind resistance varies jointly, okay, as an object's surface area and velocity. Wind resistance varies jointly. Again, we know that it's a joint variation problem. If an object traveling at 40 miles per hour, that's our velocity, with a surface area of 25 square feet, experiences a wind resistance of 225 newtons, how fast must a car with 40 square feet of surface area travel in order to experience a wind resistance of 270 newtons? Okay? So quickly, it seems a bit complex, but if we settle down to read the question slowly, we'll find out it's quite simple. First, we already know that it's a variation question and it's a joint variation question. We've been told that wind resistance varies jointly. So let's get a variable to represent wind resistance. We're using x to represent wind resistance. Varies jointly as an object surface area. So we use y to represent surface area and velocity. These are the key players. Wind resistance, surface area, and velocity. Let z represent our velocity. So now we can write out, from the first sentence, we see that x, wind resistance, varies jointly with the surface area and velocity. Y and z, product of y and z. That's our relationship. So x, if we write out the equation, is k, y, z. K is our constant of proportionality. Okay? So our aim is to find a value for k. K, therefore, is x all over y, z. From our question, let's see if we can find x, wind resistance. Okay? If an object traveling at 40 miles per hour, we have our velocity here. Velocity is z, so we can impute value for z, 40 miles per hour. So k is, already know velocity. Which other thing can we find out? With a surface area. So the surface area is 25 square feet. Surface area is y, so we know y to be 25. Okay? So next is the wind resistance. If all of that experiences a wind resistance of 225 newtons, so we have 225, we can easily find k. K is calculated to be what? 0.225. That's our k. All right? So, knowing the value for k from the first method we learned about, what do? We impute that value into the original relationship, which is x is kyz. K is 0.225, so x is 0.225 yz. So basically we have a model equation, what we'll call a model equation, okay? A model equation helps us to quickly get our unknown, because all we need to do at this point is to impute values of the known, and then we can easily find the unknown. So here's our model equation. Plug in the known values into that model. What are the known values? The wind resistance, okay? Let's check out the second set of values given to us in the question. We said, how fast must a car go? How fast? That's the velocity, z. How fast? Z. So that's our unknown. Z, therefore, is our unknown. How far must a car with 40 square feet of surface area? 40 square feet of surface area. Surface area is y. So our y here, we replace with 40. Travel in order to experience a wind resistance of 270. X is the wind resistance. So our x here is 270. So all we do is to plug in values If we do that, we'll have 270 is 0.225 times 40 times z. So 270 is equal to 0.225 over 40 is 9z. To get our z, we isolate it by dividing both sides by 9. So z is equal to 270 all over 9. And that will give us 30. So z, the velocity, is 30 miles per hour. 30 miles per hour. The next type of variation we learn about is called combined variation. The combined variation simply describes a situation where a variable depends on two or more other variables, and it varies directly with some of them and varies also inversely with some of them. So it's a combination, okay, of direct variation and inverse variation. It may involve a combination of direct variation or even joint variation and inverse variation. Now, there are steps to solving problems in combined variation. What are those steps? Step 1, using the formula method. Take care to write the correct equation, very important, for direct, inverse, or joint variation situation. Okay? Take care to write the correct equation. Find k from the formula. K, of course, is our constant of proportionality. Get a model equation. We've seen some of these steps before now. Plug in the known values and find the unknown values. Let's take the first question, question 1. If y varies directly as x and inversely, so we're seeing two relationships in one, at the same time directly and yet inversely. When you have such a situation, it is a combined variation. And we say y is 24 when x is 28 and z is 4. Find x when y is 4 and z is 6. Okay, so from the knowledge we have, we can easily write out our equation. Let's read it again. Y, using our symbol, varies directly as x. Good. But at the same time, y varies inversely or indirectly as z. It means we'll write it this way, which is more like a combination of y varying directly with x, at the same time y varying inversely with z. So this would give us something as, which of course is y varying directly and indirectly as this. So basically that's what we have. We write out the correct equation, very important, y varying directly with x and inversely with z. The equation of relationship is y is equal to k x all over z. Okay? So if we need to find a value for k, okay, we can easily impute the known values of y, x, and z, and then we'll find k. Let's do that quickly. Y has been given to us to be what? 24. So we impute 24. X has been given to us as 48. So we impute 48. And z has been given to us as 4. So we impute 4. We have 24 is equal to 48k all over 4. To isolate k, we multiply all sides by 4. We have 24 times 4 all over 48. As we further on divide again both sides by 48. All of this will give us 2. So k has been calculated to be 2. We can impute k into our original equation here to get a model equation. Okay? So we say y is equal to, k is 2. 2x all over z. Y is equal to 2x all over z. we have our model equation and we are close to solving our answer. All we need to do to find our unknown is to plug in the known values and then we can find the unknown. So we have values for our y. Y is 44, z is 6, and x is our unknown. So we impute value for y, 44, z to be 6, and x is the unknown. So that would give us 44 is equal to 2x all over 6. You can isolate x to become 44 times 6 all over 2. And this is 132. X is equal to 132. If f varies directly as g, that's on to the next question, and inversely, so we have both direct and inverse. When you see such a question without being told, you know at once that it's a combined variation. If f varies directly as g and inversely as the square of h, and f is equal to 20 when g is 50 and h is 5, find f when g is 18 and h is 6. So again, make sure you write the correct equation. You said f varies directly as g and inversely as the square of h. So here's our relationship. And of course, this is same as k g all over h squared. Now, if we plug in known values, we can find what our k value is. F has been given to us as 20. Okay, k is our unknown. G is 50. So we have 50k. And h is 5, so we have 5 squared, which is 25. K therefore is 25 times 20, and of course all over 50 here. And that will give us 10. Okay, 5 here, 5 times 2, 10. So k is 10. We have a value for k, 10. That value we impute into our equation of relationship here. Okay, so f is equal to 10g all over h squared. This becomes our model equation. Okay, so we can easily plug in the known values to find our unknown values. Okay, the unknown value there is f. Find f when g is 18. So we plug in the value 18 for g, and h is 6. So 6 squared is 36. So we have 180 all over 36, and that would give us 5. Therefore, f is 5. Let's take another quick example. The volume of gas varies directly as the temperature and inversely. Okay? Those two terms tells us that it's a combined variation question. Inversely as the pressure. If the volume is 230 cubic centimeters when the temperature is 300 degrees Kelvin and the pressure is 20 pounds per square meter, what is the volume when the temperature is 270 degrees Kelvin and the pressure is 30 pounds per square centimeter? All right, so quickly we've determined that it's a combined variation problem. What next to do? We'll write our variables, okay? We'll get out our main terms, which are the volume of gas, temperature, and pressure, okay? And append variables to them. That is, select any variable of your choice. Okay, so we've chosen here to use x to represent volume of gas, y to represent temperature, and z to represent pressure. With that, we can quickly signify the relationship from our question. The volume of a gas varies directly. Okay, x stands for volume. We put our symbol of proportionality. Directly as temperature, y stands for our temperature. And inversely as the pressure. Okay, so z stands for pressure. So here's our equation of relationship. Okay, of course, we know that x here is ky all over z. K representing the constant of proportionality. Okay, so here we have the equation of relationship. Next, we try to find a value for k. And to do that, we need to impute values of x, y, and z. From our question, x, which is the volume of gas, is 230 cubic centimeters. So we plug in that value. Next, y is our temperature. Temperature is 300 degrees Kelvin. We also plug in that value. And the pressure is 20 pounds. So we plug in that value. 230 is equal to 300 K all over 20. K is found to be 230 times 20 all over 300. That gives us 46 over 3. So we have a value for K. We take that and plug it in to our equation of relationship. That gives us a model equation. So we have 43 over 6 times y over z. And this is our model equation, okay? Our model of equation is quite useful in that all we need to do to find the missing variable is to impute our known values. X is the value, or x is the variable in question. We've been asked to find the volume. The volume, of course, represented by x. So x is the unknown. Y is given to us. Y is the temperature. Temperature is 270 degrees Kelvin. And of course, Z is the pressure. Pressure is 30 pounds. So all we need to do is plug in those values. And we have x is equal to 46 times 270 all over 3 times 30. Using your calculator, x will be gotten to be 138. So x is 138 degrees Kelvin. Let's go on. Let's try another example of a real-life problem in combined variation. The time t taken to buy fuel at a petrol station varies directly, okay, as the number of vehicles. So we're having time. Note the key actors, number of vehicles. In the queue, number of vehicles V represented by V, time represented by T, and inversely as the number of pumps P, so number of pumps. So our variables have already been given to us. No need to write down our own available in the station. In a station with 5 pumps, it took 10 minutes to fuel 20 vehicles. Find the number of pumps required to fuel 36 vehicles in 15 minutes. So quickly, our sentence here, the first sentence tells us that it's a combined variation because we have both a direct relationship, okay, and an inverse relationship together in a question. So it's a combined variation. So quickly we write out the correct equation of our relationship. T, which is the time taken to buy the fuel, is directly proportional to what? The number of vehicles, V. Okay, and inversely proportional to the number of pumps. So that's our relationship. And of course, T is kV all over P. So we intend to find a value for K, our constant of proportionality. K, therefore, okay, would be Tp all over V, using our knowledge in change of subject or formula. Okay? So we impute values for T, P, and V. Let's go back to our question. A value for T, time it took 10 minutes, times P, the number of pumps, 5 pumps, all over V, the number of vehicles, 20 vehicles. So we have 50 all over 20. This gives us 5 over 2. So we have a value. K is 5 all over 2. We impute this value back into our original relationship. Okay, remember our original relationship? T is equals to kv all over p. Now we know what k is, so we say T is equal to k5 all over 2 multiplied by v all over p. So we have 5v all over 2p as t. This is our model question. We're coming close to getting our answer. What next we need to do is to impute the known values into this model equation and we'll get our unknown value. So we've been asked what? Find the number of pumps. The number of pumps. That is P. Find P. P is unknown. When you have 36 vehicles, so V is 36. And time is 15 minutes. T is 15. Let's impute that value where 15 is equal to 5 times V, which is 36, all over 2P. Of course, if we carried out our inverse operations, we'll have 30P is equal to 5 times 36, which is 180. So P, therefore, is 180 over 30. And that is 6. So the number of pumps, P, is 6. We need 6 pumps, okay, to fill 36 vehicles in 15 minutes. The last kind of variation we'll learn in class today is called the partial variation. Partial variation. Partial variation consists of 2 or more parts that are added together. Examples are M is A plus BT, where A and B are constants. T is X plus. So that's the key thing to take note of. They are added together. One or more parts. Okay? So we have 2 constants, X and Y, and then V squared. E, another example, is equal to A MH plus B MV squared, where A and B again are 2 constants. In partial variation, there are at least 2 variables, such as A and B. These constants have to be found separately. Let's see the steps to solving partial variation questions. Okay? Using the formula method, step 1, set out 2 or more equations from your given data. 2, solve them simultaneously to find the value of one of the constants. Remember, most of our equations have 2 constants. So just try and find one. Substitute that value that you have found into one of the original equations. And then you will get the value of the second constant. So now you have the values of the 2 constants. Use those constants to create a model equation. And finally, plug in the known variables to find out your unknown variable. Let's see the practical application of all of this. A number P varies directly as Q and partly inversely as Q squared. Given that P is 11 when Q is 2 and P is 25.16 when Q is 5, calculate the value of P when Q is 7. So again, take notes to read it carefully so that you know that it's a partial variation question. The question says varies directly as Q and partly inversely as Q squared. Partly. So the key words to take note of are part. So you hear terms like part and all of that. Okay? To write this out, you say P varies directly as Q. P varies directly as Q. A is a constant. And partly inversely. So partly means, okay, you have an inverse relationship. Q squared. So it's over Q squared, where K again is another constant. So you have two constants, A and K. And we have the written relationship from this question as this. From our question, we are required to create two sentences. Two sentences. Let's look at the values. P is 11 when Q is 2. So from our original equation of relationship, from this original equation, we can use our values to have two sets of equations. 11 is P is equal to Q here is given to us as 2. So we have 2A plus K all over Q squared. 2 here squared is 4. So K all over 4. We have our first equation. Second one says P is 25.16 when Q is 5. So we have 25.16 representing P. Q is 5, 5A, plus Q squared is 25, so K over 25. And then we have a second equation. So we have two equations that we need to solve using simultaneous method. I'm sure we can revert back to our video on simultaneous equations to see how we can solve questions such as these. So you have 4 times equation 1. We're trying to prepare the equations because there is nothing to cancel out. So remember we said prepare them, create something that is equal in each of the equations so that we can cancel out by knowing which of our operational signs to apply. If we multiply equation 1 by 4, okay, we would have 4 times 11, 44. 2A times 4, 8A, and then we'll cancel out our fraction, okay? So another reason also we are using 4 and 25 to multiply both equations is to cancel out, okay, our fraction, to make it easier for us to work with. So all of that multiplied by 4 gives us 44 is equal to 8A plus K. We have equation 3. The next equation also will multiply by 25 in order to remove the denominator, in order to do away with fractions, okay? So all of this, 25.16 times 25, would give us 125A plus K. And then 25.16 times 25 would give us 629. All right? So now we have our two sets of equations. There are things that can cancel out here, K and K. So what do? We simply subtract 3 from 4. Equation 3 from equation 4. K would cancel out K, and then we can easily solve for A. So we have 629 minus 44 will give us 585. 125A minus 8A will give us 117A. K minus K will give us 0. So we have 585 is equal to 117A. A therefore is 585 over 17, which would give us 5. So we have the first constant we can find to be A. Next, we try to find our second constant, K. To find K, we pick any of the equations, however one we think is the simplest, and then we impute our known value A, and then we'll have K. Let's pick equation 3. We can impute A here to get the value K. So A is 5, we say 44 is 8A, which is 8 times 5 plus K. 8 times 5 is 40. 44 is 40 plus K, of course. K is what? 44 minus 40. K is 4. So we know A to be 5. We know K to be 4. We can go ahead to use all that we know to find what we require. Calculate the value of P when Q is 7. Calculate P when Q is 7. We can impute these values into our original equation to form a model equation. So imputing that value, we have P is equal to AQ 5Q plus K over Q squared. K is 4. 4 over Q is yet unknown, Q squared. All right? This is our model equation. Now we can impute the values given to us to find P. We said find P when Q is 7. So wherever we find our Q, we replace with 7. P, therefore, from the model equation, will give us 5 times 7 plus 4. All over 7 squared is 49. 5 times 7 is 35. So we have P is 35 plus 4 over 49. Of course, we would have all of that to be 1719 all over 49. Okay, so P is 1719 over 49. Writing it in a proper manner, we'll have 35 whole number, 4 over 49 as our answer. Let's take another quick example. V is partly constant and partly varies as M. If V is 45 when M is 10 and V is 87 when M is 24, find V when M is 18. Okay? From our first sentence, of course, we know that V is partly constant. So we do our constant of proportionality A plus K, which is our other constant, and I said partly varies as M. So we have our equation. Now, from the first sentence, we have values that we can impute into this equation to get our first equation. All right? So we have V to be 45 is equal to A plus M is given as 10. 10K. That's our equation 1. Okay, in the same sentence, we find also that V is 87. A plus M is 24. So we have 24K. Equation 2. All right? To solve this, we make use of simultaneous equations, which we learned in one of our earlier videos. Okay? So we simply subtract equation 1 from 2. And in doing that, A will be eliminated, so we can easily find our value for K. Let's go on. 87 minus 45, that will give us 42. A minus A will give us 0. And of course, 24K minus 10K is what? 14K. So 14K is 42. And therefore, K is 42 over 14. And that will give us 3. So K is 3. Therefore, we can easily impute our K is 3 into this original equation to get our A, that is the second constant. All right, let's do that. Let's use our equation 1, since we already have some values there. From equation 1, okay, we impute the value K. 45 is equal to A plus 10 times K is 3. So 45 is A plus 30. A therefore is 45 minus 30. A is what? 15. So we have values for K and values for A. Now we can impute that into our original equation here to get a model equation. V is equal to 15 plus 3M. Okay? So we have our model equation. Now, to answer our question, we're asked, remember, to find V. When M is 18, all we need to do is to plug in the value of M into our model equation, and we'll have a value for V. Let's quickly do that. V is what? 15. That's 15. 15 plus 3 times M. M is 18. Okay, so we have 15 plus 54. V is 15 plus 54, which gives us 69. So 69 is our answer. Now let's take another example that is a live word problem that involves partial variation. The cost of running a hotel is partly constant, okay, and partly varies as the square of the number of people staying in the hotel. The cost of accommodating 5 people is 200,000 naira, and the cost of accommodating 8 people is 395,000 naira. What therefore is the cost of accommodating 12 people in this hotel? So quickly, the word partly, constant, partly, varies, tells us that it's a partial variation. And how do we write out, okay, our original equation? The cost C is equal to partly constant. We have our constant there. And partly varies as the square of the number of people. Let P be the number of people. So we have our second constant. Remember, we have two constants. Number of people P, we said the square of them. So we have C is A plus KP squared. Now, from this original equation, we can go ahead to form our first and second equation. From this sentence, we have some values given to us. Cost of accommodating 5 people is 200,000 naira. So P is 5. We have therefore C is how much? The cost, 200,000. 200,000 is equal to what? A is a constant plus K is another constant. They are both unknown. 5 people, we know that to be 5, and of course this is squared. So this is 200,000, okay, is equal to A plus 25K. Equation 1. Second sentence says the cost of accommodating 8 people is 395,000 naira. So we have 395,000 naira. It's A plus 8 squared. Remember, P squared. 8 squared is 64. So we have 64K. That's our equation 2. So we have 2 equations, which we must solve simultaneously. Okay, quickly look at our equation. We have similar terms, A and A. We do a quick subtraction, and then we have, okay, our equation. So we subtract 1 from 2, because 2 is, of course, larger than 1. So we subtract 1 from 2. 395 minus 200,000 is 195, correct? 64 minus 25K is 39K. A minus A is 0. So we've managed to eliminate A. 195K is equal to 39K is left. K, therefore, is what? 195K over 39, which is 5,000. So we know K to be 5,000. Next, we try to find A. We have our first constant. Let's see if we can impute the value of K into any of our equations. Let's choose equation 1. Impute 5,000 to represent K in equation 1. What would we have? 200,000 is equal to A plus 5,000 times 5 squared. 5,000 times 25 is 125,000. Okay? So A is isolated when we subtract 125 from both sides. 200,000 minus 125 is equal to A. 200,000 minus 125 is 75,000. So A is 75,000. We have our A value and our K value, and we can impute that into our formula here to have C is 75,000 plus 5,000 P squared. This is our model equation. So all we need to do to find the cost of accommodating 12 people in the hotel is to impute known values into this model equation, and we'll have our unknown. So let's do that. 12 is the number of people we require to find the cost of accommodating them. P is 12. So we simply impute P into our model equation. C, therefore, will be 75,000 plus 5,000 multiplied by P squared, which is 12 squared. So our cost, C, for accommodating 12 people in the hotel becomes 75,000 plus 720,000. And that gives us 795,000 naira. Now, another quick example. The resistance to the motion of a vehicle is partly constant and partly varies as the square of its speed. At 30 kilometers per hour, the resistance is 496 newtons, and at 50 kilometers per hour, it is 656 newton. Find the resistance at 60 kilometers per hour. All right, quickly. From terms like partly constant, partly varies, of course, we quickly understand that this is a partial variation question, okay? We may write the equation of our relationship as, let R represent our resistance, A plus K, S representing our speed. Remember, it's the square of the speed that was given to us. So we have R is A plus K, A and K, of course, being constants, and S squared, which is the speed. All right? From the second sentence of our question, we can get values, all right, to get our first equation. Let's quickly do that. We have 30 kilometers per hour as the speed given to us, and the resistance as 496 newtons. So we say 496 newtons is what? A plus 30, which is the speed, 30 kilometers per hour, squared, and K, which is our constant. 30 squared is 900, so we have 496 is A plus 900K. Also, to get our second equation, the other values given to us are speed as 50 kilometers per hour and resistance as 656 newtons. So we have 656 is A plus 50 squared, 50 being the speed, 50 kilometers per hour. Of course, 50 squared is 2,500. So we have 656 is equal to A plus 2,500K. This gives us our first and second equation. All right? If we quickly look at our two equations, we find out that they are like terms that we can easily cross out. So it means that we can simply subtract our equations, to get our subsequent equation as an answer. All right? So we subtract equation 1 from equation 2. 656 minus 496 will give us 160. A minus A, of course, will give us 0. It cancels out. 2,500 minus 900 will give us 16. So 160 is 1,600K. To find our value for K, we simply divide 160 by 1,600 to give us 0.1 as a value or as an answer for K. Now that we have one constant, we also need to find our second constant, A. To do that, we impute this value of K into any of our given equations 1 and 2. Let's use our equation 1 to find the value of A. 496 is what? A plus 900K, remember? K now we know to be 0.1. So we impute that value 0.1. It means that 496 is equal to A plus 90. A therefore is 496 minus 90, and that gives us 406. So we have both values for K, 0.1, and values for A, 406. We can impute these two values into, okay, our original equation. So we have R is equal to 406 plus 0.1 s squared, s representing speed. This becomes our model equation. To get the unknown, that is the resistance that we've been asked to find, okay, we simply plug in value for our speed. Then we'll have a value for the resistance at 60 kilometers per hour. So the speed is 60 kilometers per hour. Let's replace our S here with 60. R is 406 plus 0.1 times 60 squared. 60 squared times 0.1 is 360. So we have 406 plus 360, which gives us 766. So our resistance is what? 766 newtons. We've come to the end of our class for today. Let's do a quick recap to see if we remember all that we learned. Okay? We said where we have a variation, where one quantity varies as the product of two or more quantities, we call it joint variation. That is, y is proportional to xz. And of course, we write that equation as y is kxz, where k is our constant of proportionality. We also learned about the combined variation. We said the combined variation describes a situation where a variable depends on two or more other variables, also varying directly with some, while at the same time inversely with others. We said it may involve a combination of direct or joint variation and an inverse variation. And lastly, we learned about the partial variation. We said it consists of two or more parts that are added together. In partial variation, we said there are at least two variables such as A and B. Of course, we've become familiar with A and K. Those are the variables we chose, to use. Of course, in each of these variations, we did calculations on how to find, answers to questions in joint variation, combined variation, and partial variation. I'm sure you had a nice time. But before we go, we'll quickly take two quick questions just to see if we remember all that we learned today. Question 1. If A varies jointly as B and C, and A is 7.5, when B is 6 and C is 3, find A when B is 8 and C is 9. Okay? So from your question, of course, we can quickly read that this is a joint variation question. So A varies jointly as B and C. So A is KBC. And we said that A is 7.5 when B is 6. So our equation of relationship we've written as this. Next, we try to find a value for K. K will be what? A all over BC. Where A has been given to us as 7.5. 7.5 is 15 over 2 multiplied by 1 over BC. Okay, B is 6 and C is 3. So we have 15 all over 2 times 6 times 3, which is 36. And of course, this would give us 5 all over 12. 3 here, 12. 3 here, 5. So we have 5 over 12 as our value for K. What do we do next? We put this value of K into our original equation to get a model equation. So A is 5 over 12, which is representing K, BC. This is our model equation. Now, the question says, find A when B is 8 and C is 9. All we need to do is to impute those values and we'll find our A in the model equation. So A is 5 over 12 multiplied by B times C. B is given to us as 8, and C is given to us as 9. Okay? So 2 here, 6, 2 here, 4, 3 here, 2, 3 here, 3. We have 5 times 4 times 3, all over 2. 2 also cancels our 4 to give us 2. So we have 5 times 2 times 3, and that is the value for A. 5 times 2 is 10, 10 times 3 is 30. So A is 30. Let's see which of our options carries the correct answer. Is it A, B, C, or D? Of course, option D is very much correct. Let's take the last question. A number of minutes needed to solve an exercise set of variation problems varies directly as the number of problems and inversely as the number of people working on the solutions. Now, it takes 4 people 36 minutes to solve 18 problems. So we have our first set of values. How many minutes will it take 6 people to solve 42 problems? So again, read your question carefully and try to find out what kind of variation question is this. Okay? It says varies directly and at the same time inversely. Okay, so we have what? A combined variation. And how do we write that out? Let's impute M to represent M, to represent the minutes, that is the number of minutes. P to represent the number of problems. And Q to represent the number of people. Okay? If we wrote out a relationship, we'd have M, which is the minutes. The number of minutes needed to solve an exercise set of variation problems varies directly as the number of problems. P varies directly as P. And inversely as the number of people. Inversely Q. So we have our original relationship as M varying directly with P and inversely with Q. Of course, this gives us M is Kp all over Q. Okay, now we are looking to find K. Let's impute values, known values here, and then we'll get our value for K. The second paragraph of our question says it takes 4 people. So we have 4, 36 minutes. All of this is 36. We have K unknown. Our P problems, 36 minutes to solve 18 problems. So P is 18. 18K all over 4 is 36. K therefore is 36 times 4 all over 18. And that gives us 8. K is 8. So now that we know what K is, we can impute into this equation to give us a model equation. Okay, so M is 8P all over Q. This is our model equation. To get our unknown, we simply impute the known and then we'll have the unknown. So what is our unknown? How many minutes will it take? How many minutes? Our minute is M. So what will M be? Will it take 6 people? Q is 6. People is represented by Q. To solve 42 problems. So problems is P, 42. So we have 8 times 42. 8 times 42 all over 6 will give us our value M, that is the number of minutes it will take 6 people to solve 42 problems. 8 times 42 all over 6 will give us 56 for an answer. So we have 56 minutes for 6 people to solve 42 problems. Let's see which of our options here carries the correct answer. Is it A, B, C, or D? The correct answer is option B, 56 minutes. And so, this is the end of our class for today. I'm sure you have learned so much. And by the next time we see again, you would have been so very good at solving variation problems. I hope to see you in my next class. For me, it's bye for now.